Just a quick show of hands. Who here is not familiar with serverless? Oh, okay. You're doing a good job. You're doing a good job. Okay, who here runs serverless in production? Okay, so pretty much everybody. Who here only runs serverless in production? Okay.
I wish.
Cool. So it's a pleasure to be here. I'm going to talk to you about a topic about building a serverless CMS. I'm going to focus on the actual serverless architecture and some of the challenges with those architectures. Okay? Before we start, just a brief intro. So I'm the founder of Webinary Serverless CMS. So I've actually built a serverless CMS. You can say I know what I'm talking about, but don't ask tough questions. I previously worked at a company called Akamai, which is currently a leader in CDN cybersecurity space. I also built the world's first smart umbrella. So, fun fact. You can follow me on Twitter at Sven Al Hamad. All right. Why serverless? I think everybody here is familiar with the benefits, so I won't waste too much time on this, but in an essence, like if I need to summarize why serverless is so important, it's because it allows us as developers to spend less time worrying about infrastructure and more time on actually solving the business problems that our company is paying us to do. Cool. Now, let's talk about the serverless CMS architecture. I've divided the architecture in 4 different areas. Otherwise, it would be just one big blob of an architecture, and it would be very hard to go through that. But in terms of like those 4 parts, I want to focus on our front end, basically serving your single page app or serving your pages, right? So it's a CMS. You need to serve those pages. I'm going to focus on the backend. So how does the API look like? What is the architecture there? And then I've extracted 2 services specifically from the backend side, the file service, which is handling the uploads, downloads of files. And in case of images, how do you actually resize an image and how you can architect around that. And one other bit is the security service, just about how do you do security when it comes to serverless in terms of user authentication, roles, scopes, permissions, and all that. Okay? We'll do questions at the end. So, but I mean, if you got a question in the meantime, raise your hand. I'm willing to take it. So, because often I know when people tell me questions at the end, I forget my question by the end. So, in terms of front end, okay? So, 3 main areas we or anybody building a serverless CMS should focus on. Well, the first one is, where is your single page app code stored? How do you serve it? Okay? You want to make sure that's performant. Then you need to worry about bots and crawlers, SEO, okay? Because, hey, it's a CMS. You need to index your content needs to be discovered. So how do you serve those bots and crawlers? Specifically, in the context of if you're using Node and JavaScript as your language of choice. So with JavaScript, some things are tough, like server-side rendering and so on. And the other bit is definitely avoid cold starts. Yes, we can avoid cold starts, okay? And just to put things in question, I'm not talking about a Jamstack CMS, which you need to build and deploy, right? I'm talking about a dynamic system where you have an admin side of it, you write a new blog post, it's immediately visible on your page. No rebuilding, no tooling, no whatsoever. 100% a dynamic system, okay? All right, so in terms of the front-end architecture, this is kind of how it looks like. I'm going to break that down even more just to focus on some of the more particular flows in terms of serving files, serving pages, and so on. But overall, what we have here is a CDN. I mean, you could argue you could do serverless without a CDN, but you can't. Especially when it comes to serving pages, serving static assets, and things like that. You do want to put a CDN. No matter what you do on the internet, put a CDN. Even if you don't cache, put a CDN. You're going to get so much optimizations from the TCP/IP optimizations and the network behind the CDN, just in terms of performance. It's out of the box. It doesn't cost you much. Okay, so we have a CDN. Then we have an API gateway, HTTP gateway, or any type of a gateway you want. But you need it to manage basically calls for your lambdas. This lambda here is a lambda that serves your pages. Okay?
What's a CDN?
CDN is a content distributed delivery network. Basically, it's a network that is distributed globally, many servers in different networks around the world. So instead of when a user needs to open your website, it doesn't need to go to your server. It goes to that POP, which is much closer to him. It has a smaller latency, and a CDN offers caching. So you can store the file onto, you can have like 100 copies of your file on 100 different edge nodes on the CDN, and it can be served from an edge node. It's way, way, way faster. Okay? So CDN, it's a good question. So I always assume people know. It's the basically, yes, it's the first entry where your client request lands. So it always goes to the CDN, okay? And it handles caching, and then later on routing. I'm going to talk about that a bit more. So we have this lambda to serve our pages, and then we have a database on the backend side, okay, from which those pages are served. And then we have another lambda that's going to handle server-side rendering. But when we besides that, an S3 bucket. I'm talking AWS terminology. Is everybody familiar with that? Okay, if somebody's not, so basically this is file storage. Okay, API gateways, I believe API gateway everywhere. These are your serverless functions. Okay. Now, when it comes to actual flows, so I took that same diagram, just extracted some of the flows to make it easier to follow and to understand. The first and I would say most important flow is getting a page, okay?
If you talk in AWS terms, where's the EC2? Where can I expect it?
EC2 is, I could put it like somewhere here, but it won't do much. We're talking serverless here, no EC2s. It's a banned keyword. So when we're talking about getting a page, okay? Now, although this process here looks very simple, it is not. It is anything but simple, okay? So returning a page, actually a client requests a page, let's say a blog post, hits your CDN, doesn't have it cached, and then basically all the request goes all the way to the site lambda, which gets the page from the database and serves it back. Now, the page in the database, that is the key here. What you want to keep in your database is a server-side rendered snapshot of your page, meaning in the admin interface of your content management system, when your content editor writes a page, when they publish a page, create a server-side rendered snapshot of it. So who's not familiar with SSR and server-side snapshots? Two hands. Okay, so basically what happens with JavaScript is when you open a page that is rendered by JavaScript, you send a bunch of JavaScript to the client. That JavaScript boots up. Then it calls the API to get the content. Then it assembles the content using React or something, and only then presents the content to the client. Okay? That works well when your browser is the client. Okay? But that doesn't work at all if a bot or a crawler comes to your site, because they do not read JavaScript. And if you read Google's website, hey, Google, do you read JavaScript? Google will say yes. Do not trust it. It does not do that. It often breaks or just has some lousy output. So, and other engines, Facebook, for example, if you shared your face on Facebook or LinkedIn or Reddit or Twitter, and you don't have single server-side rendered page, they will just display a blank widget when you share it, right? It wouldn't display an image like an open graph share with your page title underneath it. It will just be blank because they have crawlers that can't read JavaScript. So the crawler comes to the page and the page is blank for them, okay? So that is important that from even the serverless aspect, when you serve, when you have a page that is powered by JavaScript, you can't serve it as a JavaScript to the client. Usually without serverless, you don't mind that because you can immediately, your EC2 instance can immediately render that server-side rendered page and serve it to the client in a matter of milliseconds, right? With a Lambda, that is not the case, especially if you have a cold start problem, okay? Plus, Lambdas are not usually performant enough to do those snapshots in short period of time. Like we took a 4 gig Lambda, for example. It takes it between 4 and 6 seconds to generate the snapshot, okay? That is a very costly mechanism, and Lambdas just do not do that well. So back to that page editor. When your content editor creates a page and clicks publish, in the background, you want to generate that snapshot of that page, and that's the result of that snapshot is pure HTML, okay? You want to store that snapshot to the database, okay? So when a proper user request comes, all you serve is that snapshot, which is really small, and there's no need to do any computing, heavy computing there. You just serve, hey, here's the content. Now, another thing to worry about there is that that page is also dynamic, okay? So what you do is you serve the HTML and CSS, which has the content and the style sheets. So for the client, the page looks nice. Then the second process kicks in. The second process is the process where you rehydrate the page. Rehydration is a process where you serve the HTML and CSS, then asynchronously reload the JavaScript, and then once the JavaScript is reloaded, the page becomes dynamic. For the client, that is usually transparent or invisible in most cases, but it is something that you need to do, otherwise your page navigation wouldn't work, and some of the API calls just wouldn't populate the data properly. But to keep in mind in this case is that it's super important to have that snapshot done up front, because serverless just doesn't do that well, but if you do this flow here is going to take you, even with a cold start, is going to take you anywhere between half a second to 2 second stops, because this Lambda here is really, really small, okay? Now, the beauty of that snapshot is that it allows you to cache the snapshot onto the edge. So on a subsequent request or other clients hitting that same edge node on the CDN, they would get that page served in a matter of milliseconds. 50 milliseconds, 100 milliseconds. Those are the times we are seeing. So it's really nice that you can build a 100% serverless backend here and then still cache the page here. Now, there's a big challenge with that. What if your editor comes and edits the page and republishes the page? Okay, so he changed the content. To keep in mind on your CDN is the fact you need to have a mechanism that when you republish a page, you need to delete the old snapshot from here and from here. Luckily, AWS has really good APIs to do that, so you just issue an invalidate command for the CDN, okay? And if you want to go a step further, that you completely avoid this, is when you do the invalidation, automatically pre-populate that onto the CDN. But you have to understand that the CDN is a distributed system, so you might pre-populate it on few nodes, but few nodes won't have it still, okay? So this case here will always happen, just rarely. Cool. Now, in terms of serving your static assets are your CSS files and your JavaScript files, okay? What you want to do is, so I saw quite a lot of practice online where people serve those assets from Lambdas. I would not recommend that. There's no benefit in doing that. What you can do is on the CDN, on that very same CDN, you can say everything under /static, use S3 bucket as an origin. This is just so much simpler, really fast, scales quite nicely, okay? So with this overview here, let's go another slide back. Well, apparently not. Oh, sorry. Let's do this.
Question as well.
Yeah.
How do you keep your JavaScript and snapshot in sync? They have to be compatible.
Yes, so it's a very good question. It's a very tough answer. It's going to take me another hour.
Is there a default mechanism for that? Or
So it is hashing. So what you do is with every deploy where your JavaScript changes, you create a hashed version. So let me go let me go just a set back. Give me just 1 second. So here, right, you wouldn't have such a simplistic path, static main.js. You would have static /hash. Hash represents that specific build for that version of your application. And in that, you're going to have your JavaScript files. And pages referring to that specific build will still load that specific version of JavaScript. You do need to think about also cleaning that up after a while, so making sure that you invalidate those pages and that they actually start using your new version of JavaScript. So that's one thing. But another thing is if you're always careful in your latest version of JavaScript that you don't have any breaking changes, then this approach here that you always load from static main.js is fine. So it depends on how you build your application. We use Webpack and hashing to get around that, purely because we had users that don't want to invalidate that cache, want to keep it, and they want to load those pages with those previous versions without breaking them. So we need to keep several snapshots of their applications on S3. And yeah, just by hashing and having that version built gets around that problem. But it's complex to manage, quite complex, I would say. So let me just see why my clicker stopped working. There we go. OK, so in terms of actually creating a snapshot, how it looks like is it's pretty much the same flow. This flow happens in the background. Your CMS fires that flow every time you need to publish a page. OK. Now, the Lambda that is doing the snapshot should be so this Lambda here takes on the page request, but that Lambda does not do the snapshot. The reason is that this Lambda serves pages. It has to be really small in size, okay? And also, you don't want to allocate a lot of resources to her because it can be costly if you serve billions and billions of pages that are not cached quite or have a big long tail, right? So to avoid cold starts on serving a page, you keep this Lambda small. But then you have this Lambda, which is the Lambda specifically designed for building those server-side render snapshots. That Lambda can be massive. Like, it can be like 50 megs of JavaScript up there, easily, right? Depending on how big your system is. Plus, like I said, we've allocated 4 gigs of RAM here. It still takes several seconds to generate that. But we don't care because this process happens only when a content editor clicks publish, and it happens in the background. So fine with us. But yeah, just keep those two separate. That's kind of the point. As a quick summary in terms of the things to think about when it comes to coding a serverless CMS in terms of the front end, is you should use an S3 bucket. That is, I think, the best way, the best location to store your static assets. And make sure you don't use a Lambda to serve those assets, but use a specific origin on CloudFront, which is the CDN. Bots and crawlers, so server-side rendering is really important. This might be JavaScript specific, but today is a world of JavaScript when it comes to web, I would say. So yeah, have in mind that that you allocate enough resources to these and do the SSR snapshots always in the background. Rehydration to load dynamic content. So when you serve the SSR snapshot, if you still want to do API calls and that your application has to have certain client functionality, make sure you rehydrate. There's like 5 or 6 different approaches and strategies you can use to serve static stuff and then pull in the JavaScript. Rehydration we found is the best for us. Yeah, question. Thank you. Should be, hopefully. Thank you. In terms of performance, so you can completely avoid cold starts in majority of cases. Get that snapshot, put it onto the edge, and let the edge serve it. It is 100% serverless, and it scales to bazillion requests if you need it, right? Do the dirty check in the background. So when a rehydration happens, let's say there's a specific case that can happen. Let's say you have a home page which loads the 10 latest posts from your blog, okay? And then your content editor writes a new post. You don't know that you need to clear the cache on the home page, right? Because how would a new blog post know it's connected to the homepage? It doesn't, right? So what you do in that case is your CMS, when somebody does such an event that it publishes a new page, has to crawl through previous pages and allocate which pages have dynamic elements like page lists and things like that. Then it doesn't do anything on them. It just sets a dirty check flag to true. What that means is when somebody loads your page, when a rehydration event happens, in the background there's a check, parallel check. It doesn't slow down the user perception of how page loads. That check checks if this page actually needs to reload its cache, right? If it does, it fires that SSR snapshot again in the background, completely out of sight, out of mind to that user. And all users after him will get served from cache, but a fresh copy of the content, okay? There's a lot of these mechanisms, but I will show you one thing is that, I don't know what's with notifications, but hey, we're gonna get there. In terms of getting all those mechanisms right, this blog post, we wrote it. It is a 45-minute read. That is at least what Medium says. So yeah, if you really want to go deep into this complexity, and it is quite an advanced topic, do have a look at that blog post. Another thing, so just again to rephrase, split the SSR lambdas from the ones serving your site. The CMS should create the snapshots in advance every time somebody publishes a page, and it should automatically refresh the cache when the content is changed. Cool, that is front-end. The front-end is, I would say, the most complicated bit, okay? It is usually really simple if you are not dealing with dynamic systems, but this is a dynamic system. It's also really simple if you don't care about proper handling of caching, which we do. So that is another thing that makes this whole story complex. But let's shift the focus to the back end, okay? On the back end, so two things to keep in mind is you want to focus on having a lot of small services, not having big monoliths, because we want to move to microservices, we want to do serverless. Teams are, well, it's much easier to manage that type of an architecture and scale it. But also one really important point is pick the right database. If you get this wrong, it can be so painful. And I'm talking from first-hand experience here. So a backend architecture looks something like this. It's actually rather simple. So your client does a post request, or it can be a request to a RESTful API, or here we have a GraphQL API. Anybody not familiar with GraphQL? Okay, so GraphQL is a way of building APIs that you always post everything to a /GraphQL endpoint. It can be slightly different, but there's a post payload. That payload actually has the instructions for the API in terms of what data you want to get back, which queries you want to execute, and things like that, right? So it's more powerful that it can describe in a very good way about what it wants to get back, okay? It's got way more advantages over RESTful, but it's a new type of an API. But this architecture is the same regardless, okay? With one slightly different point. So again, we go through the CDN, through the API gateway to one Lambda here. Now this bit is specific to GraphQL. This is Apollo Federation, okay? Anybody dealt with Apollo here? No? So Apollo is a GraphQL gateway. Basically, you see here, these are your services. So let's say this is your pages service. This is your security service, which returns the user. This is your internationalization service, which returns the languages. And I don't know, this is a form builder service, okay? Each of these services exposes different mutations and different queries to the client, okay? But some of these queries, for example, might be interconnected. For example, a page might reference a user, okay, as a type, as a data type. But the user data type is exposed by the security service, okay? What it happens is that each of these services exposes its data sets and its queries, but this guy here groups it all together and it exposes it as a single GraphQL schema. So this is specific very to GraphQL, but why GraphQL is really important here is because this becomes a universal communication bus for you, where even when services need to talk to each other, they go through it, okay? And this is also important because this is the key where you're going to cache queries, where you're going to cache results and things like that. So Apollo is a very successful company. They are used heavily in enterprise space as well, but they're open source. But through them, this bit here with your services can grow as you can have thousands of services here, but to know which service is responsible for what, you just open the schema that this guy kind of stitches together. It makes it super easy to find, hey, I need this data. Hey, actually, it's exposed by this service. This guy will tell you that, okay?
Is that your API server then?
Sorry?
Is that your API gateway?
Yes. So this is it's a Lambda still, so it's a serverless function that runs Apollo gateway, but it sits behind an API gateway. So you don't want the API gateway to control that. You want this guy to control that. It's so much easier to scale this bit, and you get the schema out, and schema is what kind of describes your services. It describes you what services are exposing, what data you can get back, how they are interconnected. So this is something that GraphQL does out of the box, but in serverless world, you have to think about how to scale that, and that's why you need this Lambda here. Now, another challenge with the API is that all these services need to go to the database, okay? Pick the right database, okay? That is the key. You need a database that has an HTTP public endpoint, meaning that you use an API to interact with the database that uses HTTP. The moment you have that, you're not worried about keep alives and keeping connections open and so on. But if you pick a database that doesn't do that, that requires keep alives and TCP/IP connections, you're in a world of pain. Why? For example, we picked MongoDB here. Okay, so MongoDB is still, in a way, a serverless database because we run it through MongoDB Atlas. It's an auto-scaling zone. Scales up when you have a higher demand, scales down when it's a lower demand. You pay not per usage, but per how much it's scaled out or in, right? What happens is that if this service, for example, gets hit with 1,000 requests in parallel, it will create 1,000 instances of your Lambdas. Each instance will create a new TCP/IP connection to your database, okay? It's going to suck up 1,000 connections, which is fine, okay? But then another problem happens. Let's say 900 of those 1,000 users, they go away. What happens is that Lambda, when it scales down, when it removes and destroys those instances no longer used, it doesn't properly tear down IP connections, TCP/IP connections. Mongo keeps those connections open for all 1,000 clients still, but only 100 are alive. What you end up is with a zombie connection problem. You're going to have 900 zombie connections, okay? If this cycle repeats a few times, your MongoDB is going to run out of connections that it can actually use and give to proper users that want to actually get some data back, okay? It's a big, big problem. Like, we scaled this to like M15 or whatever. You still deplete them, right? What another thing that happens, just another second, is if you have, like, say, 500 instances of this Lambda, and you redeploy your code, AWS is going to bring in new code, tear down all the instances, and bring up new ones. Again, all the instances are going to cause a big zombie connection problem for you, okay? When you have a database that doesn't use TCP/IP, but you use APIs or HTTP to access it, you don't have that problem, okay? Yeah?
How are actually the lambda-to-lambda calls that you have there, for example, between C and D?
Yeah.
Is it a direct call, or is it
So,
a destination?
So what we did here to go around that zombie connection problem is we introduced something called the database proxy. Each of these services, when they do database calls, we actually proxy them through a Lambda invoke. We have a specialized layer that takes that call to the database and actually sends it to this Lambda. And only this Lambda opens the connections to the database. And also, we've capped how many instances of this Lambda you can have based on the amount of connections that MongoDB can handle. So we need to sometimes even throttle the requests here, but we save the database from running into too many zombie connections. Plus, when you re-upload your code here, you won't tear down any MongoDB connections because all the connections are kept here. Okay? I think there was a question first there.
Yeah, I was only wondering if there's a normal database behavior to open to the zombie connection.
Yes.
Only MongoDB?
It's not. So all databases that require TCP/IP connections have this problem, including MySQL. Yeah, all. Yeah. Question? Yeah.
You actually built yourself what's now called the Lambda RDS proxy?
Yes, but for MongoDB it doesn't exist. So we built exactly that. Sorry?
It's only for RDS.
It's only for RDS, meaning MySQL, Postgre, and MariaDB. Yeah. Another.
You're just moving the problem of the HTTP to the web server that's running on the database because you also have a TCP/IP connection with HTTP. How does it
Because
don't have the problem with
it's different because HTTP is stateless and doesn't require any keep alives. It can require keep alives to avoid handshakes and re-handshakes on the SSL socket, but with HTTP you don't establish a tunnel that needs to be kept open, right? Because the moment the database responds to that HTTP, it closes off the tunnel. So it doesn't want to even keep it open, so there's no problem with zombie connections. DynamoDB, FaunaDB, they all work in similar ways where they have HTTP layers or API layers in front of them to work in that way, and that works really good with serverless, right? But the moment you have to have MySQL or MongoDB, you need to kind of think about how to keep that in mind. Okay? Going to speed up slightly. Just a summary of what I was talking about. If you want to learn more about how we did the MongoDB proxy, you can read on our blog. It's a whole blog post. This one's about 15 minutes, so it's not like the first one. Cool. Moving to file service. I specifically extracted this one because it has its own set of problems. So you want the file service to be scalable. You want it to handle really large files. And potentially you want it to handle images in a different way. In terms of an architecture, it's slightly more complex than others, but it's not that bad, right? Let's start with uploading a file. A client, because Lambdas can handle, Lambda as a proxy can handle a 6 meg payload, right? That's not enough, so you can't upload 100 gig file. It doesn't work. Well, what you do is, you take the metadata of that file, meaning the file size, the name of the file, the metadata, but without the body. The metadata is going to be like 2K, roughly, regardless if the file is like 5 bytes or 5 gigabytes, okay? You send that to your file service. So this is the CDN, Lambda, the Apollo gateway, because it's an API request, and this is your service, the file service. What this service does is takes that metadata and creates something that's called S3 pre-signed post data. It's basically creates a token, okay? Sends that token back to the client. The client using that token sends the whole file with the body this time and the metadata and the token to an S3. This S3 bucket is private, okay? So it's not accessible otherwise. But with that post data, it can access it and it can write to it. And this way, you only send like 2 kilobytes here, but you can send here a 100 gig file. The beauty of this approach as well is that you can activate accelerated ingest, accelerated transfer on S3, which accelerates even the upload like drastically, right? So you use that. This is how you want to handle this upload process. So it's a 2-step process, but it scales really nicely. Now, when the client wants to retrieve the file, okay, it goes through a CDN, through the Apollo gateway, to the Lambda function. Now, this Lambda function, if the file is smaller than 6 megs, it can retrieve it from S3 bucket and send it downstream. You can also set the TTL headers if it doesn't need to be private. It can then be cached on the CDN and served from the CDN afterwards. But if it's larger than 6 megs, it can't send it back because it can't load that body and to send it back downstream. In that regard, what you can do is create a specific URL that's only public for X amount of seconds, okay? And send a 301 redirect from the Lambda to that URL. And that way, the client, using that URL, loads the file directly from S3. That's only if the file size is really big, because it can't travel through Lambda. It's a more complex process, but one you need to think about, okay? Now, if it's an image, then you can easily add like other headers. Hey, send me this image at 800 pixels by 600 pixels or whatever, right? This Lambda can retrieve that and know that command, and then offset the work of resizing to a much larger Lambda that's running sharp or something to create new image instances. That Lambda will store those image instances to the S3, notify this one, hey, you've got those resized images now on S3. This one will get them and send them back to the client, okay? But you might have now 10 different versions of the same picture in different image sizes and stuff like that. In the CMS, when somebody deletes an image, okay, you want to have triggers here that when a file is deleted, that it triggers a specific Lambda that just takes care of cleaning up all the image sizes and all the other images that are linked to this master image, okay? So think about cleaning up after yourself. But yeah, you got 3 separate processes here, serving a file, uploading file, and triggering a file delete. Question?
The difference between C and D?
C and D. So this is Apollo Gateway. This is the gateway that we had on this slide here. Give me just 1 second. So this is the gateway that then routes the request to a file service. Let's go there. Yeah. But it's also good to note that you do not have an Apollo gateway when you're serving a file, because GraphQL doesn't work with binary, okay? So this Lambda here is directly the Lambda that's going to serve the file, but this here is actually a post request to the GraphQL to get the token, so it goes through the Apollo gateway. Okay? Now, specifically to the pre-signed post data, we have, again, a blog post. It's a short one, but this one is getting like a few thousand visits every other day. It's like number 2 or 3 on Google for using this mechanism. Cool. Just a quick one. When it comes to security, logging in, managing users, user permissions, user roles, and similar, what you want to do is contain the business logic of roles, permissions, and what the user can do or can't do within your system. You don't want to move that into an external system like Cognito, things like that. But what you do want to have in Cognito are your user pools, meaning a user opens a login form, user submits the login form directly to Cognito. Certificates are expiring. It submits the login form directly to Cognito. If the Cognito service finds the user, it sends back a Cognito token, okay? Now, you don't want your backend to be tightly coupled with Cognito. So what you do is you send that token from the client through the API to the security service on your side. The security service validates with the Cognito that the token is actually valid, links it to the proper user on your database, loads up his roles and permissions, and exchanges the Cognito token for a JWT token that your system owns, okay? And then sends that JWT token back to the client. On all subsequent requests, the client sends back your JWT token. The benefit of this mechanism is that if you remove Cognito and use ZeroAuth or Zero or any other service, your roles, permissions, scopes are still part of your business logic. You will just exchange that other third-party token again for your own, and everything works still, okay? So this is the proper way of doing this. I saw users bundling everything here. Do not do that. There's really no need for you to do that. Cool. Now, building all that, well, we actually built all those architectures, so these are not theoretical models. These are models that we've tested, proven, and iterated through 100 times. It took us about, I would say, 14 to 16 months to get to those models and know that they work. So you're not in a world of pain. We do have a CMS for you. It's called Webiny. It is a CMS for serverless web development, we use Node, MongoDB, GraphQL, and React. Currently, we're running only on AWS. Others will come later. Webiny is 100% free and open source. So you don't need to pay anything. You just take it, scale it, sell it, resell it, do whatever you want with it. We are close to 2,000 stars on GitHub, although we just launched the self-serviceable version 3 months ago. Okay, and we've got almost around 20 contributors. Okay, so it's a really active community that's behind it. What our mission is to empower developers to create serverless applications. Imagine if you need to build an application that has all these layers. It's going to take you half a year just to get to the Apollo gateway so you can start writing your service with proper user security layers, file layers, and everything above it. With Webiny, you can take that and start immediately writing that. You do not even need to use it as a CMS if you don't want to. Well, you can build with Webiny websites, GraphQL APIs, applications, and microservices. So it's a serverless development platform in a way. The CMS is more of a showcase. In terms of like ready-made apps, we've got a page builder. So this is that system with the publish, with the SSR mechanisms and all that. It's working, right? Again, here you drag and drop React apps with business logic. It doesn't need to be static HTML. We've got companies that want to build business dashboards using this mechanism because it works. Another thing that we have is a form builder, so for lead generation, again, serverless. So if you have a flash crowd and you're worried about if your system can handle X amount of leads on a booking system, this is serverless. With Webiny, you as a single developer deploy it, and you can immediately handle millions and millions of requests because that's the beauty of serverless. And we have a headless CMS coming soon. So there's going to be a full-featured headless CMS version of our whole system. To get started, we got a whole documentation portal with a quick starter guide. And you can find us on GitHub, Twitter, and our website. And finally, we are hiring. If you want to join our team and do all stuff serverless, 100% serverless in production, so give us a shout. We've got 3 minutes for other questions, if anybody has. Yep.
We tried that.
So my first, I've got one question. Is that so with serverless? How do you validate your functionality? So normally you have an OTAP development street, I can imagine, but there are so many components in there. When you want to deploy new functionality, how do you do that at Webiny to validate new functionality and that nothing breaks, regressions, etc.?
Yeah, so, well, first of all, we got a lot of tests, both unit tests and Cypress tests. So Cypress is a testing tool that actually boots up a browser and tests everything. Yeah. That's one thing. The other thing is we got a very complex deployment mechanism, which is part of the open source version, which has support for stages. So when we release a new version, we can release it to a specific stage, right? And then you can do it on the DNS to do a canary release and send X% of traffic there if you want. And then we also have Webiny supports a plugin for Lumigo, so we track what's going on, and we got also other dashboards to track it. But it is challenging, yes. Serverless is hard to monitor, track, and debug.
So you do have separate environments for...
yes, separate environments as a best practice. So in that regard, I don't think serverless kind of differs from what we do with EC2 instances and stuff like that. So, yeah, question behind you.
About the part that you mentioned, avoid making monolith lambdas.
Yeah.
I was wondering whether you're using GraphQL or not. For example, for every services, for every get, post, put on API gateway, do you create a separate Lambda function for fetching data or updating stuff?
So Webiny, in particular case of Webiny, we use GraphQL post only, and there is just /GraphQL was defined on the API gateway. There's nothing else, okay? And because with GraphQL, all services go through the /GraphQL URL. There's no like REST where you need to have a bunch of URLs for each service. With GraphQL, everything goes through that GraphQL. Then it hits the Apollo gateway. The Apollo gateway is your API router. so it knows through which service it needs to call to get and fetch the data to fulfill the GraphQL request.
That sounds like a really good solution, but if you're using REST because you want to expose those services
No,
to
no.
other interfaces?
So, for example, we do have another project which is using Webany, and it's using a webhook. A webhook needs to be exposed under a specific URL, right? Webany underneath uses serverless components for deployments. So there's a YAML file in which you can say, besides /GraphQL, I have /services or /something that routes to this specific function. Webany will bundle that for you using serverless components and deploy it, so you will get a new endpoint on the API gateway if you need it for REST services.
Right. And it's going to be one Lambda per post put.
It doesn't need to. You can route multiple to the same Lambda if you define it like that in the configuration file.
All right, great, thanks.
Any other questions? Yeah?
Good. Yeah, so in your examples, you were just using Lambda and nothing like Fargate. How do you deal with the concurrency limits that you have by default in AWS?
Yeah, so we don't care so much about concurrency limits. We let the services scale to any level they want. The only service where we do really care about concurrency limits is the database service, the database proxy, because we need to cap that one so it doesn't overflow the database connection pool.
Okay.
So, but other than that, it's serverless, so we don't care. Like, if you boot up 5,000 parallel requests, Webany will handle it, so you don't need to worry about that.
All right.
Are you known with AWS Amplify? Because it also creates a lot of Lambda functions by GraphQL schemas.
Yeah.
And what's your opinion about it?
It's a good hello world example.
Yeah.
Yeah.
Yeah, it's a bit too
Don't
much,
try
right?
to do anything outside than what it's designed to do. The moment you do that, you're better off actually scaffolding everything on your own using Cognito and stitching the services together on your own. We've tried it. It just didn't work well for us because we were doing something that wasn't meant to do. So, yeah. But for beginners and to do something very, very simple, it is a good starting point because it's easy to use and deploy.
Okay, thanks.
Yep. Any other questions? No? Well, I hope you learned something. Thank you.
All right, thanks. Hi, everybody. Already 8 o'clock. I know it's late. Who's still awake? I know I am. All right, most of them put their hands up. If your neighbor didn't put it up, give him a small nudge to make him awake again, because we're going to talk about a serverless mindset and why we have to leverage a serverless mindset. Hola, Pola. What's in it for us? Go back, please. Yeah. Serverless, for me, is about enabling the power of the cloud for your organization. Not just about enabling, it's about unleashing the power of the cloud for your organization. I'm going to use the buttons here because we have some problems. All right, works better. But before we're going to talk about that, let's talk about me. Who am I? I'm Nick van Hoof, working currently at Cloudway. Couple of years experience with cloud and serverless technology. Big fan, evangelist, serverless. I call myself an evangelist because I want to spread the word about this great technology and mindset. And that is also what I want to do tonight. I want you to go home and to have an idea of what's in it for me. Okay, so let's start talking about that. And to start talking about serverless and the serverless mindset, we have to identify what serverless is. And that's a hard question to answer because there's always a lot of fuss in the community about what is serverless. And now it's even unpopular to try and answer that question because so many people have tried it. But I think we should still do it. And if I try to answer that question as simple as possible, then I picture my girlfriend, who is this one, by the way, and I tried to identify how would I explain this to her. And because she didn't know she would be in the picture, I decided to black her out. And I decided to black her out, and how did I do that? I wanted to recognize her face in the picture and then draw a black rectangle over it. And so I did that, and I leveraged a cloud service for this. And you say, okay, but you could have just drawn a black box over her face. Yeah, and that's true. So if I would explain the story to my friends, it would already be harder. And you see, the service recognized all of the faces. And then I tried to black myself out, which also succeeded. But then I was surprised because on this picture, there's actually another picture. And it even saw those faces over there. So wow. Oh. And that's what it's about for me. Using serverless technology, I didn't have to worry about how I would recognize those faces in the picture. No, I could just worry about showing those pictures to you. And that's what serverless is about. Offloading hard things to the cloud and focus on what you want to build. So that's why I say I didn't have to worry about that, recognizing faces. Serverless is worryless. It's not without worries, but less worries because you can leverage those cloud services to do things for you. Offload that hard work to the cloud and focus on what matters to your business by leveraging all of those services. And then so leveraging the power of the cloud, indeed. Statement. In this current era, software will make or break your company. And I think this is really true. Great software will make you a great company. That goes for almost all companies because almost all of your company is running on top of software. And having great software will allow you to differentiate yourself amongst your competitors. Look at what do we actually want from great software. Why do we want great software? What's important for our business? Now here, this shoe. Who knows this shoe? Someone knows it? Yeah. It's the fastest shoe in the world, already the second fastest right now. Actually, I own it. I own a pink shoe. So it stands for speed. For our systems, we want speed. We want them to work quickly. We also want agility, and there I don't mean that you have to work with your team in an agile way. That's another concept. I mean that if you want to adapt your business process, your software should be flexible enough to adapt itself to your adapting process. Because you want to be able to innovate all the time. That's how you're going to differentiate yourself. And of course, you also want to trust your services. You want them to be up all of the time. And you want them to be secure. So if you could leverage security from the cloud, that would be great. And if you have all those things, then I think that software can really be a differentiator for our company. It can really be something that allows us to make the difference and go faster than our competitors. And the people tell me, oh God, software is such a cost. And that's true. Software is a big cost if you're sitting on a bunch of legacy systems that are so inflexible that if you have to change one field in your front end and your back end also has to change something that you're testing for weeks, then it becomes a cost because you're very inflexible and it doesn't allow you for any innovation any longer. But if you leverage the power of the cloud, if you design in this new way of thinking, software can be an opportunity to differentiate yourself. And that's what it's about. It's about business agility. It's about the concept of you having a business process, then wanting to adapt that, and then your software being able to adapt itself to the way that you want it to work. Because you always want to think about new strategies, new marketing campaigns, new way of working, and to allow that, your system has to be agile, your system has to be flexible. And that's why we need to be cloud-wise. We need to show some cloud wisdom here. And for this, I found a tweet of Jared Short. Who here knows Jared Short? Not so many yet. Maybe, of course, he's a big name in the serverless community. He's a big name on Twitter too. And he has his vision, which I really like. And he says like, okay, if the platform has it, then use it. And that's exactly what I was telling before. Leverage the services that the cloud built for you. They hire great people. It's very hard to get into Amazon because you have to be very smart for that. And then they build something, and then you can leverage it. Then if the platform, if the cloud does not have it, but someone else built it, like MongoDB, for example, that's not from AWS or Azure or not from the big platforms, then buy it because it's there for you to leverage. And then the third one, and this is the one I get most opposition for, if you can reconsider your requirements, then do it. And of course, you shouldn't always change your requirements to your software. But if you want to take full advantage of those cloud services, then you, of course, you need to know what these services can and cannot do. That's with every technology, you have to keep that in mind. And if you want to leverage those advantages, you have to know the features of your system, of what you can leverage, and then design so that you can leverage all of those great things. And then if something doesn't exist, or you have to implement some business logic, then build it yourself and then own it yourself. And that's a mindset that I really like, is to architect from the start, architect your own system, then run it, then test it in development, UA, then go to production, and if there's a problem in production, make sure they call you. Because you need to feel the pain if you did something bad, so that you will improve your system and update it to make it great again. Make it great again, okay. Managed services. The first big advantage of the cloud is using those managed services. And people, when I explain this to business people who are not as nerdy as myself, I use the following example. We all know this guy, I guess. He's a great soccer player, and he wants to make goals for his team. Oh, and by the way, does someone see the mistake on the picture? It's actually very hard. Something doesn't add up here. If you saw that, then you're probably watching too much soccer, because this is a ball from the Premier League, and he's playing in Spain. So that doesn't add up. Very hard, okay, I admit. All right. Okay, but this guy, he wants to make goals for his team. And he wants to do that in the stadium, of course. But he cares about making goals. He doesn't care about building that stadium. Okay, Messi, he's a rich guy. He could probably afford to build a stadium, but still, it would take him years. And he just wants to score a goal. He doesn't care about putting up security on the entrances of the pitch. That is something that should be there. He only wants to play soccer. He doesn't care about drawing the lines. No, we have a guy for that. We leverage that guy. He doesn't care about building the goalposts. No, he just wants to make that goal. And it's the same thing that I want to do and the same thing that you want to do. You want to make that goals for your company. And you do that by leveraging all of those things that the cloud offers you. The cloud offers you a lot of managed services, and then you can stitch them together, you can glue them together using here AWS Lambda, where you write your business logic, really using all of those things that were already built for you. There's another very wise guy, Forrest Brazel. I add the link here if you want to read the full article. And he made this graph about being wise and clever. What is being clever? Being clever is having a postdoc in mathematics and being able to write your own operating system, which is very hard to do, or being able to build your own databases, difficult stuff. But that's not very wise because it's going to take you years before you have something that you can get money off. No, what we want to do is we want to use all of those trusted cloud-native services because we can build on top of that. Those are great services, and we can then be very quick to innovate, which is very wise because now we can focus on making the difference again. So using those managed services will lead to speed and innovation because you can leverage all of those things that were already done for you. And using managed services also leads to, if you do serverless, then think service full. So let's dissect that sentence. Doing serverless, showing a serverless mindset, leveraging those managed services. You can now start focusing on the service that you want to offer your clients. And because you build on top of those managed services, the cloud providers, they are also competing with each other. They want to be the best. They want to be the most performant. They continuously improve their technology. You're built on top of that technology, so you get even better all the time without doing anything. And that also leads to an evolutionary architecture. You can see your system growing. You can pull KPIs out of this. The cloud services also offer. You can build custom metrics, custom KPIs, but I'm not going to go into that. But your system will continuously evolve. And if you would measure like the number of orders that I'm able to process in a certain time, you will see that continuously go up because your system is ever improving. That's the thing that we want to keep in mind. So using those managed services, we all know those guys, or if you don't, the 4 big composers of history. Using those managed services that actually gives you all of the instruments to compose your own great cloud music and make your own service build to compose the great stuff that you want. So managed services, okay, we saw that one. Now what problems will serverless solve for you? So we always show a problem, then something that we desire, that we really like, and then the solution that the cloud offers us for this. The first one, we don't want to waste time configuring our system. We don't want to update our databases all the time. We don't want to patch our servers. I don't want to manage my own Kubernetes environment. Who here manages his own Kubernetes environment? Oh, okay, that's great. Because that would take a lot of time. That's a hard thing. Maybe there's a good reason to do this, but for me, that would be very hard because I'm also not experienced with Kubernetes. So I would leverage a managed Kubernetes by the cloud because I want to focus on my business process and I'm leveraging those managed services. Now, we also see this graph, and we know that we can have a high load. The holidays are coming up, Black Friday is coming up, the load will be high on our systems. However, we don't know how high, we just know we need to provision a lot of our services. We need to be able to handle that load that might be coming. So all the time you're paying here for all of that provisioned resources that you're not using. You don't want that. You want to only pay for what you use, and that is exactly what almost all the cloud services, the serverless services offer you. That is a pay-per-use model. Now, even when you provisioned for an upcoming load, you probably under-provisioned. You still underestimated your load, and now you have a problem because you're going down. So you're failing under high load because you're not able to scale. We want to be able to adapt to upscaling load. Even better, we want the cloud to scale our systems for us. And that's exactly what the cloud systems do with serverless services. They automatically scale up when there comes more load, and they scale back down when the load goes down, and you stop paying for them. So, if you go down, if something really went wrong, you don't want your whole system to go down. You want to fail in pieces. If you cannot internally process orders anymore, it would be very nice that customers can still make orders from the website. So we want to fail in pieces, and we want to build in pieces. And that's what serverless allows you to do, because it's also exactly what those functions, serverless functions, for example, are. A function means do one thing, care about one thing, and do it well. Should that thing then fail, then you can contain that to that function. And then, when a big legacy system goes down, and what happened in the past, then at 3 at night, they called me and they told me, man, this request failed. We're not retrying it automatically. You have to get out of bed, and you have to re-trigger the payload. Oh, we don't want that. Oh my God. No. We don't want that. We want resiliency. We want to do things. We want to come back up. We want to retry, and we want to recover. So should something go wrong, we want to have automatic retry behavior. That's what the serverless services do. Most of them have a couple of retries automatically. Then should something become unhealthy, if an application or an instance of a Lambda function becomes unhealthy, we want that thing to be thrown out automatically and then recover by spinning up a new instance which is healthy. That's done automatically by the cloud. And then, so we saw managed services. Then we saw the problems that it will solve for us. But let's not forget, we are developers and we also want to have a great time. I at least want to have a great time. And that's what this thing does. For example, I can now, because I defined all of that cloud infrastructure as code, I can now quickly spin up a whole new set of these of these services for myself to test something in a different region on another side of the globe. I can do that at the click of a button, because the cloud can make servers for me anywhere. It's not like in the past when we wanted to innovate, and you have, for example, you had an innovation day at work, and then all the teams, they go to their database managers and they say, hey, I need a database today because I'm going to experiment. And then they get all of those requests and they say, okay, guys, come back in a few months. We'll provision them. The cloud does it for you. Yeah? Just in a couple of minutes, you can have that database that you want, and you can start innovating for yourself. So we had 3 things. We're using managed services to offload work to the cloud. we're leveraging cloud patterns, we're leveraging cloud behavior to our own advantage, like automatic recovery, automatic retry, automatic scaling up and scaling down. And this all will allow us to focus on where we want to make the difference, and it will allow us to innovate quicker. And that way, we can really have that business agility that's so important for us to outpace our competitors. Now, you know, that's the good news story. And it's kind of like a movie. The movie starts good, and then it goes a little bit down, and then we end on a high. So let's do that. Serverless also has some challenges. The first one is a picture that I took from this blog here. The source is over there. You can read it as a whole. But what I want to visualize here is we have a bunch of heavyweight technology problems. And then we want to go to a state of where we have less problems. But we want to do that using the serverless technology because we now know that it turns out to have a lot of advantages. Of course, you have to know, and you have to get to know all of those new services. And that can take some time. If your team is new to the cloud technologies and has no knowledge at all, then start out simple or hire an expert to help you think about those cloud services. And once you get over that learning curve, you can really start leveraging the power of the cloud. And here, indeed, we see serverless offerings from Azure, from AWS, and from GCP. There are a lot of things to work with, and there are a lot of things to architect with. So using those services asks for a new way of thinking, a new way of designing your system, often thinking very event-driven and thinking in smaller components. And that can take you some time to get your head around. And even there, if you don't have a specialist in your team and you want to even try, you will fail, and then you will fail and learn from that and fail again. And so my advice is to always have someone in the team that can bring that knowledge of the cloud. And then also when I'm giving this presentation to other technical people, they tell me like, oh, but what about running things locally? Yeah, that becomes difficult. You have these frameworks that allow you to run your serverless architecture partially locally. And you can do that. You can test some stuff there. But actually, the power of serverless is in using those managed services. And those services, they are on the cloud. So that's why it's logic that you need to deploy this stuff in the cloud to test it and to see if it still works. And then I know there was a question before about how do you test those systems. Yeah, you really need to have some tests in place that test the behavior of your full system. Because indeed, you now have a very distributed system which is glued together and which asks for dedicated testing. What about big payloads? Also something that we saw in the presentation before. We saw that if you want to send very big payload through an API, that's not possible. Then you have to put it on an S3 first and then send the link, or then use that event from S3 to process it further. Or if you really want to process files of 50 megabytes and more and want to send them through your APIs, then okay, you might have to use a different technology. What about long-running workloads? For example, training a machine learning model from scratch. Maybe you can split that out. I don't know how. I always need a very big instance, a very expensive instance to train my models. So you would then have to use another technology. Or, of course, if you have long-running workloads, now I'm talking more function-specific here, the Lambda functions, they can still execute for 15 minutes, so you can still process quite a big batches, take big batches of events from your stream, process them during 15 minutes, and then take the next batch. Okay, and then time for some, oh yeah, indeed, the last one. But what about monitoring, for example? Because the system is so distributed, there are a lot of components to monitor. And then if I would have to write something myself to monitor all of those components, again, I'm started for a very long journey. I don't want that. That's why I say that the solution for serverless challenges is often to go serverless, to show that serverless mindset, which means, and I already heard the company here, for example, using Lumigo, Epsagon, Tundra. There are so many tools available for you, also cloud-native tools, that will do that monitoring and that tracing in your distributed system for you. So leverage those, instead of spending weeks trying to build it yourself. Right, time for some success stories. We have a couple of other serverless evangelists, Ben Kehu, Sheen Brizzles from Lego. They have great stories about how serverless changed their companies. We also have a couple of our own stories, but those stories, you can check them on the internet. There are videos about them. You'll find them anywhere. What I want to tell you is my personal story. And now you need to allow me to brag for 5 minutes. And it's actually a true story. So during the last 10 days, I managed to set up an application that deployed to 3 different environments, CI/CD in place, 3 different environments on 3 different accounts. Then, using a service, Lumigo, that was already someone built it for me, I just started using it. I added observability to my project. I also trained, in the last 10 days, I trained a machine learning model to predict breast cancer. Just because I can, using those cloud services. I run an IoT weather station. That's a big name for my Raspberry Pi in my home, measuring the temperature and then sending it to the cloud, saving it in the database and visualizing it. But still, I could, within that 10 days. I blurred faces from pictures. We saw that. And I didn't manage it, but I started a project to look at the picture, then get the scenery, and then start composing some music that fits that picture. That's a very hard thing to do, so it's not finished yet, but I was able to start that thing and to start interpreting what is on the picture. And that's just fantastic. It's amazing what you sometimes, if you start working at 10 o'clock, yeah, I'm an addict. You start working at 10 in the evening because you still have the edge of going programming. And then when you go to bed at 2 in the morning, you say, whoa, I've done such great things. I've innovated so much. And that's all because of showing a serverless mindset. On a personal level, but also on a company level, you can innovate so quickly. If you're showing that serverless mindset, you can really unleash the power of the cloud for your organization. On that bombshell, I like to end. If you still want to know more of this story, I'm continuously telling it on Twitter. I would like to hear and follow all of your stories. So let's keep in touch. Because I think this will be a revolution in the next years in the software industry. Last, thank you. And then I still want to make some publicity. We are here at Serverless Days in Amsterdam, it's also a conference. And we are also going to organize that in Belgium. So it's planned for somewhere in September 2020. Website is on the way, CFP is on the way, tickets are on the way. Keep your eyes open and go to serverless.be. Thank you, guys. Are there any questions? Please.
I want to ask about your experience with serverless running big jobs for data transformations, for machine learning and stuff. Because in our organization, we are using running over a lot of ECRs, EMRs to run big transformation, and we always have problem with that. How did you tackle it through serverless?
Yeah, so that's why I say for really training a model, for example, a machine learning model, I'm still using an instance, which I let the cloud spin up and manage. But I then would use serverless to do my predictions, But to train the models, I haven't found a way to split it out and to do it serverless, to do it with Lambda functions. You can still do it serverless as long as you offload as much work to the cloud as possible.
All right.
Yeah, so if I want to introduce serverless at my own company,
Mm-hmm.
I will definitely know that I will hear from everybody that they say you will have a vendor lock-in. So
Yep.
I don't know what you have to do when you have that argument of what you experience with that.
Yeah.
I mean, that's the most, given argument
Yep.
there is.
It's what, yeah, indeed, it's true. But the moment that you are starting to use MongoDB as a database, you're locked into MongoDB. The moment that you start leveraging, it's double. You want to leverage all of the cloud services, all of the things that they have built for you. So that also means that you have to commit yourself to them.
Mm-hmm.
It's logic that you will then have some kind of lock-in there. That's something that you cannot go around, but I think that is outweighed by all of the advantages and the speed that it brings. All right, guys, thanks.